Thanks for being here, everyone. And I'm going to talk about maybe a slightly different use case for container orchestration and containers on AWS that we are using internally at Copit. We call it DIT. It's Discovery Inventory Tool. And this talk will be first short introduction, overview of what this internal tool is and why we need it, architecture of the tool, walkthrough or a very short walkthrough. The architecture is pretty simple because it uses many AWS native services connected. And that's what I wanted to present, how you can build quite powerful solutions with quite a little bit of infrastructure code. So, talk quickly on a side about containers for automation, Amazon ECS overview, task definitions, Event Bridge and Event Bridge Scheduler, Cloud Query, which is a tool to gather data about inventory resources in AWS accounts or other cloud providers. How to connect securely between different AWS organizations, different accounts. Also Amazon Managed Grafana. I don't know if anyone here has used it. And then the use cases for this tool. So, ECS and EKS are the main container orchestration platforms on AWS. And I think it's most commonly used, like we used it in the lab before, for running long-lived services. Spinning up a server and making sure that it keeps running and moving it between nodes. But you can also use ECS to quite easily run short-lived tasks or scheduled tasks or on-demand tasks. And that's great for automation, data collection, and batch jobs. So for us at Copit, we have this discovery inventory tool. And it's a tool to, as we are an AWS partner and AWS consultants, we have many customers, and loads in those customers have loads of accounts and AWS organizations with resources in them. And we help them if they want to both set up their infrastructure, but also keep track of it, make sure everything is as it should. And while AWS has this data, it's hard to get a simple overview. And that's what we're using this tool for. And like I said, it's built with mainly Amazon native services or AWS primitives. And yeah, I jumped ahead of myself a bit. So this inventory discovery, it's both to keep track of inventory of all the resources in customer accounts or our own accounts. And to discover what is there. I mean, when you have enough resources and enough accounts, it can be hard to have an overview. So some things that our customers may want is visibility into it, or we want to have visibility into what is running, and cost data, compliance checking. We also have AWS config now, but this is more centralized for all of our customers. And this is just a preview of the end result. So the high-level architect, why it's called 2.0 too is because we had it and then we did it quite manually, kicked off tasks manually, but now we've defined the whole thing in Terraform code and also run it scheduled, so we don't do any manual touching of this tool. It's just running in the background and it's all managed services, so we don't have to worry about that. And I will talk about the Event Bridge Scheduler, ECS tasks, Cloud Query, this third-party open source tool. That's the heart of the service. RDS is part of it, but I guess everyone has quite a bit of knowledge about RDS, so I won't mention that. But I will talk a bit about Amazon Managed Grafana too. So, containers for automation, we are all using containers, and that's also the meetup, containers on AWS. And it's a huge advantage just to be able to pull down containers instead of having to compile something. And in comparison with Lambda, which you might normally use more for these quick jobs, using this containerized tasks on ECS, it's good because we don't have to care about runtime support or anything, and we also don't have a timeout. The task can basically run as long as possible, or as long as it doesn't crash. So that's basically the difference in, we can jump ahead here. So ECS, it's EKS is Kubernetes, so that's the full-fledged orchestration solution. But ECS is way easier to set up, and if you're using it together with Fargate, you don't have to even provision any EC2 instances or anything for the capacity. I don't know how many people here have used ECS, or are you more used to EKS, Kubernetes? Because I have not worked a lot with Kubernetes because it's scary, but ECS is anything but scary. It's super straightforward, and it's for that reason it's really nice for one-off jobs, or maybe if you want all the features of Kubernetes, yeah, sure, service meshes, etc. You don't have that with ECS, but it's a brilliant way to run and orchestrate containers. So in the Kubernetes lingo, so a task in ECS is basically a pod on Kubernetes, and a service is a deployment plus a service in the Kubernetes or EKS world. And a cluster, an ECS cluster, is basically a node group or worker nodes. But using ECS and in conjunction then with Fargate, the cluster is just an abstract concept, and you don't have to run anything in the background or keep track of anything. So yeah, Fargate, serverless compute for container with auto scaling and per second billing and isolation. Like I've now said many times, normally maybe it's used for long running services, but tasks are also a first class concept. And here I wanted to show basically how simple it is to set up an ECS cluster when you're using Fargate in Terraform or Tofu. Of course, I didn't remove that much actually. No, this is actually the full code you need to set up an ECS cluster. So create a cluster, and then the capacity provider, maybe classically it would be EC2 instances or managed EC2, but with Fargate you just say the capacity provider is Fargate, and then the capacity provider strategy is basically run everything on Fargate. And then what we run on this ECS cluster is ECS task definitions. So that's equivalent to Kubernetes pods. And it's one or more containers that are then orchestrated together. And you basically say which image and how much CPU and memory you need, set up networking, dependencies, interdependencies, which roles they have. So the task runner in ECS has one role, and the task itself has another role, where you set up what rights they have to have, which access the tasks have to have. And that is also quite straightforward to do in Terraform code. A bit more complicated because the setup of the cluster is so simple. Some of that goes here then into the task definition. This is also slightly simplified, but this is basically our tool. So when the task gets started, we have a first container here that syncs some configuration from S3 into a shared volume between two images. And then when the config sync container has run, then the actual cloud query starts running and then gather information from the different accounts and organizations. I removed the volume line there because of space reasons. And this, another part of our tool that I won't go into is GitOpsy workflow. When we add new customer, then it renders the configuration files for that customer, copies it to S3, so that the next time we kick off this discovery inventory tool, it has all the config set up per customer. Yes, and AWS Event Bridge, I guess most of you know that. No, that's basically it's a serverless event bus that you can use for loads of communication within between different services in AWS and routing events. But it can also invoke tasks, and via the Event Bridge scheduler, which is, I think, the more modern replacement for CloudWatch events and AWS scheduler, you can quite easily set up invocations of different things, lambdas, or in this case then ECS task. That's also, some parts are removed here for brevity, but it's basically also here not that tricky. You set up a schedule, and the schedule expression, you can either use this cron expression or a rate, like once per day, or a specific time point with an at expression. And then within the target, depending on which service you want to run, then in this case, it's an ECS task. So we just point it to the ARN of the task we want to run. Say how we want to run it, the network configuration. Yeah, sorry.
So for the event bridge, we can only leverage for the cron jobs or for the microservices as well. Just suppose if we have a lot of data and we want to push to get that data from like the different services.
Mm-hmm.
So we can leverage that event bridge for that as well, or it is only for the cron job?
No, EventBridge is a general event bus, but I don't know if you have a lot of data. I don't know what the payload, max payload is.
Nodes are like we have like the robust data in that, and for the, just for the microservices architecture, we can leverage that as well, right?
Yes.
I mean, if you're pushing lots of data, EventBridge isn't the right tool. SQS, Kinesis, that'd be more what you're looking at. EventBridge would get expensive.
Okay,
Quite
fine.
quickly. You want to look more into like SQS.
Yeah, just for the cron jobs and like scheduling type of thing.
Yeah, EventBridge is very good for scheduling, and if you need to listen to events in your infrastructure, it's really good at that. So EC2 instance started.
Yep.
EventBridge can query CloudTrail, that's what it's called, right? CloudTrail. You can react to events in your infrastructure.
Yeah, and if
Data.
for an event-driven microservice architecture, that would be the glue.
So
The EventBridge.
Simon is really good. Simon, you have implemented recently some EventBridge things.
Yes, but that was also for events that were, I mean, not much data and only a few per day. So I would also, I think what Jan said is very accurate.
No.
If you have a lot of data, there's
Yeah, makes sense.
Yeah. Any more comments, questions?
I think the main selling point for EventBridge is it's quite deeply integrated into AWS. It knows a lot about how to call other services, right? The targets, there's different types of targets, call Lambda. But that's kind of also its weak points. It's very integrated into AWS. So that's what it's good at.
Yeah, you can, but you can connect everything through EventBridge. Like
Just
when you write something to, yeah.
You just need an event bus, it's not the right tool.
Are you looking for something that is very application data oriented?
Actually, the thing is that if we have the keep track of the data, and if the one service has that data, and like that data will be moved to the other one, okay, and they keep tracking of that. So I was like just curious to know like EventBridge is appropriate that or like not, but like yeah, his comments is very like the cron job is a better one for that.
Yeah. So if you're looking for application to application message really stuff, look at Kafka. So Kafka is really great, and many companies use that to transport data between applications. But of course, you can also use Event Bus for that, but Kafka is probably more suited for application to application stuff.
But the thing is, like the Kafka is totally a different thing, and so just suppose if we have to leverage the AWS services, okay, and so for the microservices architecture only, because the service is the one, okay, and this is like the different services, the smaller services. Okay, so for that, I'm pretty sure like the AWS will be providing some things as well for like the data aggregation. So that was like the main point, like not the different services, but the different services of one application instead of the different application. Are you getting my point?
Yeah.
So like the microservices architecture I'm like talking about.
I have a chat with our folks who are doing the break and doing the app work, and probably they can help.
Okay, sure.
I think it's true to say you can't push data into EventBridge, right? You can't, from your application, you can't send a message to EventBridge.
Yes,
EventBridge,
you can.
oh, you
Yeah,
can.
yeah, yeah.
But it's more used for triggering off of other stuff inside AWS.
Yep. Okay. Let's see what we have next. Yes, it's just, I didn't want to take away all the details. So basically, when you kick off a task from EventBridge, you also have to make sure you have the role so that basically the scheduler can assume the role, and then you have to have the, depending on what you are starting, then you have to just allow the right the right action for the right resource. So it's not just enough to point it to the ARN of the task. You have to also have the rights to kick off the run task in the ECS cluster itself. So, oops, that was a slide I was going to remove, but so Cloud Query. If we jump back a bit, so, oops. Cloud Query, that's the core. So we use the Event Bridge Scheduler and the ECS task to run Cloud Query in a container. And that's an open source tool that is specialized for getting data from the different cloud providers. So AWS, Google Cloud, and Azure. This image is a bit old, I think, so the logos might have changed. But yeah, so it extracts, for our use case, it extracts all the data about the AWS resources using AWS APIs, and then puts it into a Postgres database. And the whole Cloud Query tool is basically, it is plugin based. So you run the container and then you give it a bunch of YAML files for sources and outputs. And you can also do some custom data transformations. They also deliver that, and there are third-party ones, because what you get out of Cloud Query is basically a boatload of tables if you use the SQL backend. And then you can use some transformations that basically create views or materialized views, so it's a bit easier to look at all the data. Yeah. So Cloud Query plus these ECS tasks and our GitOps workflow. It basically then creates lots of config files for Cloud Query, and when we kick it off, which we do once a week, this runs through, and for each of the plugins, for each of our customers, it connects to their organization and gets out all the data about all their resources and puts it into our RDS database. And Cloud Query runs for minutes, not hours. Yeah, depends on how much data there is. It can run for close to an hour, maybe. But since we are only running this rather infrequently, it's great to not have to worry about servers or anything, and the Fargate only costs money when you're using it. But here's another thing I wanted to talk about, how we can connect to all the accounts for all our customers in all of their organizations. So it's basically our task runs in our DIT account, and then it uses assume role for all the organization root accounts for our customers. There is a role there which has a trust policy that the principal has to be this account, and then we also use external ID as an extra verification that the connection or the assume role is allowed. And that's the new best practice recommended by AWS. So you don't just trust a role across different organizations, but trust an account and have an external ID. So an external ID can be any secret, basically any text string, a UUID, or what you want. So how this works, then this querying is basically we connect to this root account or the organization account, check the AWS organization data, get all the all the member accounts. And then this role that it has assumed in the organization can then assume roles, a member account role in all of the sub-accounts. And that's how it can extract all the data for all the resources in the whole organization. Any comments or questions about that? Nope. And then finally, at the end of this workflow, after we have run DIT, gathered all the data, put it into RDS, in order not to have anything to manage, basically, and just run it on managed services with very low maintenance needs. We are using Amazon Managed Grafana to build dashboards and look at this data to get an overview. And yeah, if you're using Grafana and you haven't checked out the Managed Grafana, it's quite nice because it's a managed service, and it's integrated with AWS AIM Identity Center. So it's super simple to set up, and it can connect directly to these services and more. For example, to connect to an RDS, you just connect through a VPC, and with Managed Prometheus, which we are using in another project, you just give the endpoint and they talk over AWS Private Link, and it's cross-account data collection is super easy. So in the end, after running all of these different managed services, what we end up with, sorry. And yeah, that's also another thing that's quite easy to set up in Terraform. So if you want to do authentication via IAM Identity Center, it's really not tricky. A couple of lines of tofu and you have it set up. And then we get to the end result, is that we can have overviews like this over all the regions, all the customers, and we can filter on accounts and filter on customers. And another use case is to check end of life data, so that we can be sure that all the customer services are not close to be end of life or get the extra expensive support contracts. So that we are using another plugin that's symbolized there by the hourglass. That's a quite nice service. It's a website called endoflife.date. I mean, all of this data is also in AWS and the different cloud providers, but endoflife.date is a collection of data for all the cloud providers and all the services, and also many open source and proprietary software packages. So there we can see, RDS, is it good for all the customers? EKS, Lambda, okay. So we have quite a few old Lambda runtimes lying around somewhere. And then we can, for example, drill down to EKS and pretty easily get an overview about where do we soon have to make an upgrade or remind the customer to upgrade. They've probably gotten a notification from AWS before, but here we can just double check and make sure we're on top of everything. So I think that is the presentation. So any questions or comments?
I heard AWS managed Grafana can get quite expensive. What's your experience?
Yeah, it can get quite expensive, but it's very predictable. So it's $5 per month per viewer and $9 per month per admin or editor. It depends on how many users you have.
Not depending on data.
No. If you want, there's also you can set it up for enterprise, where you have you add a key from Grafana Labs, and then you get support from Grafana Labs and some enterprise plugins, and then it's $45 per user if you have that add-on. But for just normal Grafana dashboards with the standard data sources, it's not that expensive. So the hosted Grafana at Grafana Labs, I think it's more expensive. Yeah. Yes, Toby?
Question about Cloud Query. So Cloud Query itself has like an AWS plugin that knows how to talk
Yes.
AWS API,
Yes.
and then we're using just the SIM role to drill through the management accounts. But
Yes.
Cloud Query is still running queries against the APIs of the sub-accounts of the customers.
Yes.
Okay, that's cool.
And yeah, everything in Cloud Query is basically a plugin. And that the plugin for AWS, it costs money. So every time we run those calls, it also tells Cloud Query's cloud that we ran this API, and then we pay a bit for it.
We don't have to
But the data doesn't leave our system.
we don't have to install anything in the management account other than the role.
Yeah, exactly. The role and the trust relationships. And that's everything that the client accounts need to have.
So I can chime in here a bit as well. So I actually can give you a bit of history what happened here. So because I'm the CTO at COVID, and I had the initial idea together with Roman and a few other folks when we actually grew so much as a company that we added every week more and more customers into our ecosystem. So basically, we just had a couple of dozen AWS accounts to look after because we were small, we had very little customers, only very few accounts. But then it started to grow, so we added on larger customers, hundreds of accounts. So right now it's about roughly 1,000 AWS accounts that we have touched over our lifetime. And 1,000 AWS accounts is a lot to fill Excel sheets and keep them up to date and try to do that manually, because when you start to put information into an Excel sheet, it's anyway outdated. So when we had a few issues a couple of years ago, so this was born about 3 years ago or so, when we had the very first drafts, and we had written the specs, what the issues were, and then we started to brainstorm, how can we solve it? Initially we wanted to develop our own stack, but then we quickly realized that's not going to work. It will be very hard to maintain a solution, to really build that ourselves. Then we came across Cloud Query, and Cloud Query is actually a tool that really helps you have an inventory of all your AWS accounts, or Azure or Google or whatever. And so we started to use it. And by now it's default practice when a new customer onboards to us as a company, we put these roles into the accounts. And it's in the AWS accounts, it's just a role, a policy, and a trust policy, and a different one for the job account than for the management account. So it's very simple. But with that role, and it's a read-only role on the AWS APIs, we do get the ability to query their accounts on a meta level. So we basically can see what kind of EC2 instances, what kind of Kubernetes cluster, what kind of Lambda functions, what kind of Lambda versions inside of the functions, all of that stuff. And then we collect all that data on a weekly basis, because we don't need to do that on a daily basis. There's a lot of metadata that is collected. And all that data, how long does the process run, Cloud Query? Half an hour?
Yeah,
Maybe
15 minutes to half an hour normally.
So, and right now we have maybe 500 accounts or so in it. I don't know. So,
Wow.
it's a lot of accounts. And basically, in each account, we go and we query all the meta information and put that into a database. And that's exactly what Petra has shown. And now we have the ability to run queries on top of that. And
Yes,
basically, if you're a data engineer, you can run SQL queries, or Petra and the team have now built dashboards that it's very easy to consume for people. So now we see what kind of accounts do we have, what kind of instances are there. And you all operate on AWS most likely, and with AWS, you know, Kubernetes clusters are outdated, RDS is outdated, Lambda functions need to be updated, all of these various things that you need to do. And now with Cloud Query, we can go in, have these end-of-life dashboards, and can very quickly tell our customers, hey, we should upgrade these and these things. Would you like to do that? And the tool that Petra has now made into a professional state is extremely usable, extremely valuable for us and our customers.
Yeah, I forgot about that part, the ad hoc SQL queries. It's much easier than to go to the AWS console and look for data, to just be able to write a SQL query combining data from all the customers.
You all know that you have Resource Explorer these days in the AWS accounts, but that is just for a single account, or maybe you can have it in the organization. But stand in our shoes, we have hundreds of accounts, dozens of organizations that we work with. So there, the Resource Explorer doesn't work. This is the tool, and the cost of running that tool, and that's the best thing, is it costs us about $300 a month, because it's Grafana, Aurora, and a few runs, licenses, and that's it. And Cloud Query is about $30 to $40 a month. So it's less than $500 a month that we pay to run that solution and inspect hundreds of AWS accounts. And now I shut up.
Cool. No, thank you. Thanks a lot. And
Thank
thanks
you.
a lot, Peter.